Alright everyone, I wanted to share with you a video that helps you to calculate the percentages of the A's and the T's, the C's and the G's when we follow Chargaff's rule. And so hopefully this video will help you a little bit just to see that. Let's take a look at a DNA strand. So if this was my parent DNA strand, what would the complementary strand be? We remember that T's bind to A's and C's bind to G's. Okay, that's our rule, that's what Chargaff said, and we want to find out what's our complementary strand. So if I have an A in this spot, its complement will be a T. If I have a C over here, the complement is a G. So it's always just what matches with each other. So the G complements to a C. I would have an A, T, G, G, T, C, A, T. Okay, so that's step one, is trying to understand how to get that complementary strand. Now, if we wanted to figure out what percentage of my DNA strand is adenine or guanine or cysteine or thymine, then we would go through and do a math calculation. And so let's take A's for example. If I wanted to find the percent A, I would look at the total number of the A's divided by the total number of bases. Okay, so let's do this one. For A, in my DNA strand up here, I have 1, 2, 3, 4, 5, 6, 7 A's. So I'd write 7 in my numerator. And then let's count how many bases we have total. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 bases. And so if I'm trying to figure out the percentage of A, then I would look and say, okay, I have 7 A's out of 24 total bases. And so when we do that math calculation, I would take 7 divided by, zoom in a little bit better, divided by 24. I get this decimal. If I want it in a percent, I just multiply by 100. And so that gives me about 29%. I'm not going to fool around with the decimals. We have about 29% A. If I wanted to find the percent T, again, just go up here and count the T's. 1, 2, 3, 4, 5, 6, 7. So I would again have 7 out of 24, which would give me 29%. And that makes sense because the percentages of A's and T's should be the same because A's and T's bond together. Let's look at the percent C. So again, I come up to here, I count the number of C's. 1, 2, 3, 4, 5. Only 5 of them this time. There's still 24 bases. And so again, come over to your calculator and do 5 divided by 24. And I get, and again, take that times 100. And I get 20.8. I'm going to round this to 21%. Okay, and again, this may equal over 100% because I'm rounding the numbers, and that's okay. We'll deal with that later. If I wanted to find the percent of G's, come on up and let's count the G's. 1, 2, 3, 4, 5. And so down here, 5 out of 24 gives me 21%. And let's go check the math just to see if I'm right. If I had 29 and 29 and 21 and 21, let's see what we get. So 9 and 9 is 18, 19, 20. So I'll put a little 2 there. 2, 4, 6, 8, 10. What do you know? That actually comes out to be exactly 100%. And so when we're looking at how to calculate this, you're really just taking the number of that base over the total number. Now, if you take a look at this, and it's 29C, 29T, or 29A, 29T, 21 and 21 for C and G. This is for this species. And so if you have another species, let's say, and I'm going to write this on a different marker, let's say the next species had, say, 31%, 31%, so that's 62, so that's 38, so 19, okay, we see that for species 2, And then maybe for species 3, if I was looking at a third one, maybe this one was 40%, 40%, 20%, 20%. And so we have 3 different species. How do we know which 2 are the most alike, which 2 are the most similar? They're the ones where the numbers are closer. And so if we look here, this one isn't really that far away. 21%, 19%, 20%, that's pretty close. But look at the A's and T's. If we look, species 1 and species 2 are much closer than species 1 and species 3 because there's a bigger gap. There's an 11% gap here. There's a 9% gap here, but there's only a 2% gap here. The same thing for this. And so we could say, because C and G are pretty equal, that we would say that species 1 and 2 are the most similar because they have the most similar genetic makeup. And so again, this is designed to help you to understand when you use Chargaff's rule, how to do the complementary strand, how to calculate the percentage of the DNA that is each of these bases, and then taking a look at different samples, how do you know which 2 are most related? We look at those numbers that are the most similar. So hopefully that helps, and again, replay this video if you need anything other than that, but this is looking at Chargaff's rule and calculating percentages.